All right, so these are the solutions from the Chapter 1 test that you were to complete by Thursday or Friday afternoon at 3 o'clock. This was a graded assignment, but I highly suggest that every one of you go through these solutions and redo the problems, as there were some glaring errors as I checked your work. All right, so number 1, solve the equation. Number 1 was good. Add 7 to both sides. X is equal to 22. Number 2, 2/3 x plus 5 equals 3. So first I'll subtract 5 from both sides. 3 minus 5 is -2. Now I'm going to multiply by 3 halves on both sides, because that's the reciprocal. They cancel out on the left-hand side, and I get x is equal to -6 divided by 2. So x is equal to -3. 11x plus 1 is equal to -1 plus x. I'm going to subtract x from both sides first. I get 10x plus 1 equals -1. I'm going to subtract 1 from both sides. I get 10x is equal to -2. And then I'm going to divide by 10 on both sides. So this reduces to -1/5. Some of you wrote it as the decimal, 2/10, which is fine, but I would say keep it as the fraction. Okay, number 4, I have 2 times the absolute value of x minus 3 minus 5 equals 7. First things first, you must isolate the absolute value. Isolate, get it alone. Move everything away from it. So I'm going to add 5 first. That gives me 12. Then I'm going to divide both sides by 2, and I get absolute value of x minus 3 is equal to 6. Secondly, sorry about that. Remember, 2 equations must be solved. So remember that whatever's in the absolute value bar, whether it's a positive number or a negative number, it makes our answer positive. So the reason we create 2 equations is because we have to find what value would be positive inside the absolute value bars and which value would be negative. So my first equation I keep exactly the same. I remove the absolute value bars like they're not even there. X equals 9 is my first solution. Then I take my answer and I just simply make it the opposite value. So instead of equaling positive 6, it's going to equal -6. That didn't work. Adding 3 to both sides, I get x is equal to -3 as my second solution. 2 equations have to be solved when you are solving absolute value equations. Number 5, absolute value of 2x minus 19 equals 4x plus 1. All right, so the absolute value is alone on the left-hand side. So my first equation, it's like the absolute value bars don't exist. So now I'm going to subtract 2x from both sides. I get -19 equals 2x plus 1. I subtract 1 from both sides. And then I divide by 2. So I get -10 is equal to x. We'll talk about that in a minute. My second one, the whole other side of my equal sign has to be the opposite. So, I don't know, this doesn't want to work. I make the positive 4x a negative 4x. I make the positive 1 a -1. So some of you were making the 4x negative, but you didn't change the 1. So now I'm going to add 4x to both sides. I get 6x minus 19 is equal to -1. Add 19. I get 6x is equal to 18. Divide by 6, and I get x is equal to 3. Okay, so I have two solutions here, but remember we have to check for extraneous solutions with absolute value. So we have to take our answers and plug them back into the original. So some of you are confusing what it means to be extraneous. Extraneous means an extra solution, okay? Mathematically, we got two answers, but we have to check that they make the original true. Is the original true? Okay, so we have absolute value of 2x minus 19 equals 4x plus 1. And mathematically, we found x is equal to negative 10 and x is equal to 3. So I'm going to plug that in. Absolute value of 2 times negative 10 minus 19. Is that equal to 4 times negative 10 plus 1? Now, I'm going to fast forward a little bit to, this is like number 15. If I just look at the right-hand side, I get negative 39. Automatically, I know that x is equal to negative 10 is extraneous, because remember, whatever's inside an absolute value, it makes the answer positive. So I can never get an absolute value expression equal to a negative number. So 2 times 3 minus 19, is that equal to 4 times 3 plus 1? So on the right-hand side, it's equal to a positive number, so I can't get rid of it just yet. This gives me absolute value of 6 minus 19. That gives me negative 13. So 13 equals 13. So the only solution for number 5 is x is equal to positive 3. This was your extraneous. All right, number 6. Negative 2 plus 5x minus 7 equals 3x minus 9 plus 2x. All right, I'm going to combine all like terms. On the left-hand side, negative 2 plus negative 7 is negative 9. On the right-hand side, 3x plus 2x gives me 5x. What do you notice here? It's the exact same on both sides. So this is infinitely many solutions. Or I would like you to write all real numbers. They're the only two acceptable answers. If you went back here and you wanted to, let's say you didn't recognize that right away. I could subtract 5x from both sides and I get negative 9 equals negative 9. This is a statement that's always true. So what that means is no matter what you plug in for x, it'll make the left-hand side always equal the right-hand side. So I want you to focus on that being what you write as your answer. So 3 times number 7. Okay, I'm going to distribute that 3. I'm going to combine like terms. Now I subtract 11 from both sides. 3x equals negative 18. Divide both sides by 3, and I get x is equal to negative 6. Okay, that's just a simple linear equation, multi-step. I don't need to check my answer because there's not an absolute value on there. Now, some of you like to check your work and you can see if you're right or wrong. That is totally fine. Number 8, I told you to omit that. It's apparent some of you do not know what that means. Omit means to skip. All right, number 9. I have 1/3 times 6x plus 12 minus 2 times x minus 7 equals 19. Okay, so I'm going to distribute 1/3 times 6x gives me 2x. 1/3 of 12 gives me 4. Distribute the negative 2 to the next set. Combining like terms, 2x minus 2x, they cancel each other out. So I get 18 is equal to 19. Well, what do we know about this statement? That's not true. So number 9 has no solution. This is your answer. You need to put an answer in. All right, number 10, we talked about this in class on Friday. It says describe the values of C for which the equation has no solution. So 3x minus 5 equals 3x minus C. So notice that the 3x is the same on both sides. So in order to have no solution, we just said that what's on the left-hand side cannot equal what's on the right-hand side. So C cannot equal 5. Why? Because if C were to equal 5, I have a problem that looks like what we did in number 6, where what's on the left is the same as what's on the right. So literally C can equal any number except 5. Because any other number, the 3x's would cancel, and I would get negative 5 equals negative 4. Well, that's not true, so therefore I would have no solution. Number 11, same directions. Just give the value of C that would make this have no solution. Well, we talked about this. The absolute value bars, when I see that, it has to be equal to a positive number. So literally, if C is any number less than 0, any negative number, this would have no solution. So if I just simply set it equal to negative 2, now it has no solution. So I have 13 students. I could have gotten 13 different answers from this, as long as those two things were satisfied. All right, number 15. It said, consider this equation, absolute value of 4x plus 20 equals 6x. Without calculating, how do you know x equals negative 2 is extraneous? So we looked at this. If I replace x with negative 2, so let's say we were going to solve that, I would get my absolute value bar equal to a negative number. Absolute values can never equal negative numbers, therefore I know it's extraneous. We found it mathematically, but it doesn't work. All right, and then lastly was 16. Explain to your friend she doesn't understand what the final work means. I'm going to distribute my 4. Okay. 4y minus 2y gives me 2y when I combine on the left. 6y minus 4y gives me 2y when I combine on the right. Okay, then he subtracted 2y, and you get negative 8 equals negative 8. What does that mean? It means all real numbers are solutions. Or like some of you put in the work, there are infinitely many solutions. So in an attempt to solve, you couldn't solve for y because the y's canceled each other out. Okay, so I'm putting this on Edpuzzle so I can see who views it, and I need everybody to redo their work.